Okay, so last section we're going to look at is 8.1. Okay, we'll do half of it today. We'll pick up with the next half of it next time we have class. Well, after vacation. So the goal of law of sines, I just said, is to figure out how big your sides are, how big your angles are in a triangle. We've already done that. We did SOHCAHTOA, and we used Pythagorean Theorem, and we found sides and angles. What's going to be different about this is you're not going to have a 90-degree angle. Okay? If you don't have a 90-degree angle, what does that mean? What else don't you have that's always across from a 90? You don't have a hypotenuse. Okay? So if a triangle doesn't have a hypotenuse, it's called an oblique triangle. You cannot use the Pythagorean theorem on an oblique triangle. Pythagorean theorem only works on triangles with a 90. It doesn't work in other places. You also can't do SOHCAHTOA, because SOHCAHTOA is opposite over hypotenuse, adjacent over hypotenuse. You don't have hypotenuse. So you've got to do something a little different. What I'm going to show you right now, the law of sines, you could use this all of the time. You can use this when you have a right angle. You can use it when you don't have a right angle. Law of sines is a little bit of overkill. If you have a right angle, it's easier to use SOHCAHTOA. If you don't have a right angle, you're stuck using this. So the two types of oblique triangles you can have. You could have an acute triangle. Think of like an equilateral. All the angles are less than 90. Or you can have an obtuse triangle. One angle larger than 90. Why can't you have two angles larger than 90? Yeah, then it wouldn't be a triangle. You'd need a fourth side. It's a quadrilateral. Okay. So when we're solving triangles, what do we normally use to label the sides? We use A, B, and C. And does anyone remember the name of the Greek letter that we put across from A? Alpha. And the Greek letter across from B? Beta. It's the same diagram with one extra thing. What I just circled in red, we've never had to label before. That was always 90. Now, because it's not, we have to give it a name. So A is across from alpha, B is across from beta, and C is across from gamma. G-A-M-M-A. You can draw your triangle any way you want. I usually just sketch it this way. If you want to sketch it this way, that's fine too. Just make sure when you label it, wherever you put A, put alpha across. Wherever you put B, put beta across from it. That's all you have to make sure you do. None of my sketches are going to be to scale. So for example, in this picture, alpha might be 100 degrees. It's not to scale. I just do it that way so I know what's across from what. That's all that's really important. Not the scale of your picture. All right, so there's 6 things to find. 3 sides, 3 angles. In every problem, I have to give you half of that information for you to be able to solve the rest of it. So one thing I could give you is 2 angles and a side. Okay, what would that look like? Something like this. Let's say I said this is 10, this was 100, and that's 6. That's an example of 2 angles and a side, where the side that you know is between the 2 angles. It's the side that connects them. That's different than side angle angle. That would look like this. Let's say we had an angle, another angle, and a side over here. That's angle, angle, side. Or you can say side, angle, angle. This time, the side that you know is not the one that's between the 2 angles. It's one of the other ones. Any questions on the difference between angle, side angle? Side angle, angle. Same information, different placement. And the last type is two sides and an angle. Now, when you're writing these down and describing kind of triangle, if you say angle, angle, side, like AAS instead of SAA, that's fine. This one, I put in this order on purpose, SSA. It's not nice if you write it the other way. So, stick with SSA. So, whether you're solving a problem that has ASA, SAA, or SSA, which actually I didn't draw a picture of. So let's say side, side, and the angle that you know is not between the two S's. So pick one of the other angles. That's a picture of SSA. To solve any of these three types of problems, we use what's called the law of sines. Law of sines is only used for these three types. Okay, and if you're thinking, well, wait, what would another type be that I didn't put on the board? Side, side, side. If I gave you all three sides of a triangle, up to this point, I haven't taught you how to solve that. We're not going to learn how to do that this week. There's also one other type, SAS. SAS is not one of the three I've listed. You cannot solve it with what I'm teaching you this week. So on this test, you're always going to use the law of sines. On the next test, you're going to have a choice. Is this a problem you use law of sines, or should you use law of cosines? How do you decide? If it's one of these three types, use law of sines. If it's not, you do something different, which you'll learn next week. All right, so let's see if we can figure out what the law of sines is. All right, so what I'm going to do is I'm going to label some of the sides in this triangle. Let's label A. You got to put alpha across, okay? I'm going to label B. I'm going to put beta across from it, but I'm not going to label anything else. All I need to label is two sides and two angles for what I'm going to show you. What I'm going to do now is I'm going to take this triangle and go like this. What did I just draw in? What is that?
It makes it into two triangles, which gives it two right angles.
All right, so we just created two right triangles. And the line that I drew is the height. It's called an altitude. It's a line drawn from a vertex perpendicular to the opposite side. Is the triangle on the left and the right congruent? No, that doesn't. Maybe if this was an equilateral and I did that, it would be, but this is not. Any questions on the diagram? All right, so now I'm going to cover up the triangle on the right side. Just going to focus on the one on the left. Okay, and what I'm going to do is I'm going to come up with a formula involving these three things. A, beta, and H. Remember, H stands for height. It's not hypotenuse. So try to keep that straight. What is the name of the side that we've labeled H from the perspective of beta? If you were standing at beta, it would be opposite. So we have opposite. And what about A? It's across from a 90.
Oh, wait, hypotenuse.
It's hypotenuse. So when we did SOHCAHTOA, which trig function involved opposite and hypotenuse? Sine. That's what we're doing, sine. So the sine of your angle would equal, what side, what's opposite beta? Yeah, what side is opposite beta? What did we call it? H. And what side is the hypotenuse? A. Okay, Okay, now I want to get h by itself. So how would I move a to the other side? Multiply. 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 So we just came up with a formula to find the height. It's a times the sine of beta. Any questions on the formula? I'm going to do the same thing again, except now I'm going to block the triangle on the left. Okay, but we'll come back to that. We'll call that box 1, okay, for now. Okay. I want to come up with a formula for the height again, this time involving the 3 things I just circled. So from the perspective of alpha, the side that we've labeled h is the opposite, and the side we labeled b, hypotenuse. It's the same trig function again. Sine of alpha equals what over what?
Opposite over d.
Height over b.
H over b. And now I want to do the same thing. I want to get h by itself. So how do I get h by itself there?
Multiply by b.
Multiply both sides by b. That's gone. And now I've got h by itself again, and I have another formula to find the height. It's the same height we just found before, but I have a different formula. We'll call it box 2. So I've just shown you 2 different ways to find the same thing. So if box 1 gives you a formula for the height and box 2 gives you a formula for the height, what does that mean about what's in box 1 and what's in box 2?
They're both the height.
They're both what?
The height.
They both equal the height. So what else does that mean?
They're the same.
They're the same. Box 1 is the same as box 2. So write that down. And that's basically going to give us the law of sines. So I'm going to put b sine alpha. It doesn't matter if you write box 1 equals box 2 or box 2 equals box 1. It's the same thing. So that's box 2 equals box 1. B sine alpha equals, I'm sorry, B sine alpha equals A sine beta. And the way the book usually writes the law of sines is they put B on the other side. So how would I get rid of that B? Divide it. So divide each side by B. And they usually put the A on the other side. So how would I get rid of the A?
Like that.
Divide that. And what you have left is the law of sines. Sine of alpha divided by A equals the sine of beta divided by B. Now there's a third part that we didn't prove, but looking at the pattern, does anyone have a guess what the third part of this would be?
Sine of b.
Sine of that new Greek letter, gamma,
Yeah, over c.
over C. And that is the law of sines. We didn't prove the third part. You could very easily doing what we did again, but just from the pattern, you can assume that it works, and it does. So, whenever you're using this law, I consider this 3 parts. You only use 2 parts at a time. Either the first 2 parts, the last 2 parts, or the first part and the last part. You never use all 3 parts at the same time, just 2 at a time. And what's going to happen is when you use 2 parts, there's 4 things there's 4 spots. There's a numerator on the left and the right, a denominator on the left and the right. They're going to tell you 3 out of 4 of the numbers, and you're going to fill them all in, and there's going to be 1 thing you don't know, and that's what you have to find. So we're going to go through some examples. You can still use the fact that all the angles in a triangle add up to 180. That doesn't change. But what did I say earlier you can't use anymore?
The Pythagorean theorem.
You can't use the Pythagorean theorem because if you do, you're assuming you have a right triangle. And most likely none of these problems are going to be right triangles. Okay, so does everyone have the law of sines, which I abbreviate LOS? Okay, so as I said before, they've given us 3 pieces of information. The first thing I'm going to do is make a sketch because I want to see if what they gave me, is it one of the 3 types? Is it ASA, SAA, or SSA? If it is, I'm going to use law of sines. If it isn't, for now I would just say, I don't know how to solve it. So let's make our sketch. I'm going to put A over here. That means alpha. It's got to go across from it. I'm going to put B at the bottom. Means beta goes across from it. I don't know C. I don't know gamma. So can anybody tell me what, using the 3 letters, the A's and the 2 letters, A's and S's, what type of triangle is this one?
Side angle, angle.
Yes, you know a side and an angle and an angle. If you were thinking in your head, well, wait, is it angle, angle, side? Yeah, same thing. Okay. The point is, it's one of the 3 types I put in the notes earlier, so this is a law of sines problem. All right, now we know it's law of sines. Next thing, we're going to make a table. The table is just to organize the information we already have and the stuff we need to find. All right, so I'm going to fill in what I know. So that's 20. That's 60, and that's 4. So you need gamma, C, and B. Okay, what can we find first? That's not too bad. You probably could have figured it out before I even showed you the law of sines.
The other angle.
The other angle. And what would it be in this case?
100.
100. Yep, be 100. Now, when we did this before, what did I say about using what we just calculated to find something else? Not to. Okay, I said if you find something, don't use it, because if you make a mistake finding it, and you use it to find something else, then you're going to get that wrong. Well, that works fine for right triangles. But for the kind of problems we're doing, you're going to have to use gamma to get C. You have to. So if you just got gamma wrong, you're going to get C wrong. You can still get B right. B has nothing to do with gamma, but C does. Okay, so it's really important that we get things right. All right. So now we're going to use 2 parts of the law of sines. Always use the part that has the row with everything in it. The row with everything in it, this problem, is the A and the alpha. So we are going to use, if you look at the 3 parts, we're going to start with that. Sine of alpha divided by A. So fill that in. Sine of, what's alpha? 20. Divided by A is 4. And now at this point, what you put on the other side depends if you want to find B or find C. So which one do you want to find first? It doesn't matter. B. So to find B, now I'm going to use this part. Equals sine of beta over B. Sine 60 over B. Okay. So we have 3 numbers, one thing that's not a number. How do you solve a proportion? What do you do? Cross multiply. So you're going to have 4 sine 60 equals B sine 20. And the last step is to get b by itself. So right now you have the sign of 20 next to it. How do we get rid of the sign of 20 and put it on the other side? Divide. Yeah. Divide each side by sine 20. Sine 20. That's your answer for b. We need to type that in. But that's the answer. Any questions how we solved that equation for b? That's what every problem is like today. Just like that. Also, all of these are going to be in degrees. So you don't have to worry about switching between degrees and radians. It's not that you can't use radians. I chose not to. So they're all degrees. So 4 sine 60. And now before I type anything else in, what's it important that I do right now on my calculator? So I'm in degrees. If I don't do this, the calculator is going to give me an answer, but it'll be wrong. I have to close that parenthesis. Tell the calculator I'm done with sine 60. Now I'm typing in the denominator. Divided by sine 20. Is it important that I close the parenthesis on the 20? Not really, because there's nothing else coming after it. If you want to close it, go ahead. If you don't close it, you get the same answer. Right? So we get 10.128. And that's B. Now, how many rows do I have in that table that are completely full? 2. So technically I have a choice. To find C, I have to use a row that is completely full. Which row should I use? The top row or the middle row? Yeah, the top row because everything was given. So at least we're not using B. Okay? I can't avoid using gamma. I'm going to have to do that right now. So now let's find C. So start with the same thing you started with last time. Sine of alpha over A. So sine 20 over 4. And now you're going to set it up using this. Sine gamma over C. So can somebody tell me what's going to go in that fraction on the right? Yep.
Sine of 100 over C.
Sine, one more time?
100 over C.
Yep, sine of 100 over C. And after a while, you kind of get used to the cross multiplying and what's going to happen. So I usually just jump right to this step. C is going to equal 4 sine 100. But then when I multiply the other way, I'm going to have to divide by sine 20 to get C by itself. Because it would be 4 sine 100 equals C sine 20. And then I divide by sine 20. If you don't want to do that, you want to do the step in the middle each time, that's fine. Just do it like we did the last one. But that's what you get. Any questions on that? Okay, so we'll type it in and see what we got. If you typed it in last time, all you have to do is type it in again and change one number. Well, maybe 2 numbers. Make it 4 sine 100 over sine 20. Okay, so we get 11.518. Now, can I check that with the Pythagorean Theorem? Can I try a squared plus b squared and see if I get c squared? I might have typed it in wrong. 4 sine 100.
I got like -2.21.
If you get a negative for a side, something's definitely wrong. Are you in degrees?
Yeah.
And you typed it in exactly like that? If you type it in exactly like that, you should get 11.5. Anyone else get anything different than that? No? Okay. So if you're getting a negative still, let me take a look after and I'll double check it with you. So what was it? Yeah, Pythagorean Theorem. Can I check it with Pythagorean Theorem to see if it's right? No, why not?
It's on the triangle.
This is not a right triangle. If you check this with Pythagorean Theorem, you're saying this is 90. No, it's not. It's 100. So Pythagorean Theorem is not going to work. So you have to do it just like we did. Okay. So that's the angle side case. Any questions on that one? On a test, that would be 3 different problems. I basically give you partial credit for each answer you get right. Okay. All right, let's try this one. So this time we already have a picture, so it should be a little quicker to figure out which type it is. So using the A's and S's, which type is this one? Yep. This is ASA. It's different than the last type we did, but it still falls under one of the 3 types that you do use law of sines. I'm basically going to do one of each type. That's what I'm kind of doing. Okay, so let's set up a table. Now, before I start filling it in, remember what I said about law of sines. You have to have a row with everything in it. That's the only way this formula works. Okay, we've got, actually you tell me, what's the 40? They didn't label it, but you should know what it is by its placement. It's beta. And what about the 45? That's alpha. And same thing with 4, they didn't label it, but it has to be, it's the only side that we don't have labeled, C. Do I have a row with everything in it? Do I have a row that I could find something and then have everything in it? Yes. So I have to find gamma first. Okay? You can't do A or B until you get gamma. So what's gamma going to be? 95. Now it's very, very important we get gamma right. If we get gamma wrong, we're going to get everything wrong this time. You're going to use gamma to find A. You're going to use gamma to find B. So don't get gamma wrong. Just add these up very carefully and subtract from 180. Okay. Any question on how we got gamma? Now, at this point, you can find A or B first. It doesn't matter. So let's find A. What row do I definitely have to use to find A? I got to use the row that has A. So can someone set up, using the first row, what would my fraction be?
Sine 45 divided by A.
Yep. 45 over A. And what other row do I have to use? C. If you try to use B, you're going to end up with 2 letters in the same problem. That doesn't work. 1 letter per problem. So if I fill in row C, what would the other side look like? Sine 95 over 4. And now we cross multiply. Can someone tell me when I cross multiply, get A by itself? A will equal what times what divided by what? 4 sine 45.
A sine.
And then divided by
A sine.
just sine 95. So you did the step in the middle where you put it equal, that's fine. Then you'd have to do one more step that we just did. Okay, so type that in and see what you got. 4 sine 45. Close the parenthesis, very important. Divide by sine 95. Okay, 2.839. Okay, now that I have that, there's a couple of things I can tell you about B. I know B is across from the smallest angle, so I know it's the smallest side. So it is less than 2.8. I know that. So if I get an answer that's bigger than 2.8, something's wrong. Okay, so now let's set it up to find B. Okay. Anyone think they can tell me how to set up my proportion to get B? Yeah, Casey?
Sine 40 over B.
So she's using the row that has the thing we were missing. You got to use that row. Yep. And now she has a choice of which two rows to use because they both have everything in them. Let's see which one she picks.
The sine 95.
Yep, that's the row I would go with. The 95 is something you calculated, but you have no choice. You have to use it. And it's better to use things that aren't decimals than things that are. All right, so get B by itself. And we're going to have 4 sine 40 divided by sine 95. And I know it's less than 2.8. Does anybody have what it comes out to? Yeah.
2.580.
2.580. Thank you. I didn't double check it, but based on our numbers, it seems reasonable. It's smaller than 2.8. So I think we're good. Okay, so that's the second type. Any questions on angle side angle before we look at the last type? Okay. So in this type, they gave you 2 angles and a side. This type, 2 angles and a side. This type, 2 sides and an angle. So, whenever you have side-side angle, you have to be careful with that one. There's something that can happen here that can't happen in the other 2 cases we did, or any other case we'll ever study with this section. Okay, side-side angle is the only time this can happen. It could end up that you just get one answer. It's just like the problems we've been doing. You get one answer for each thing you don't know. Or it could happen that you get 2 answers for each thing you don't know. So that would be like getting 2 different answers for A, 2 different answers for B, 2 different answers for gamma. Okay. So it could be 1 solution, 2 solution, or it could work out that the information I gave you doesn't work. It's no solution. And if you're like, well, how could you be given information that doesn't work? It's possible. I'll show you next time with a sketch. Right, but this is the only time you have to be careful with that. Other than giving you that little piece of information right there, now we'll just do a problem and see what happens. So this time I've already set the table up for you, and it's using the same numbers we had up above. Okay, do I have a row with everything in it? Yes.
Yeah, A and alpha.
Yes. Because I have a row with everything in it, that tells you that it's a law of sines problem. The fact that I also have a row with nothing in it, and no way to find anything in that row, tells you it's the case that's side-side angle. Okay? If you look back at the last 2 problems, you always had a row, you never had an empty row, ever. Now we have a completely empty row. That's not the case we like to deal with, okay? Because we have to look at all this extra stuff and be careful. All right. Also, when you do this kind of problem, you are forced to find everything in a certain order. Does anyone have a guess what you have to find first? There is no option. Yeah. We can't get C because we don't have gamma. We can't use a row that's completely empty. There's not enough information in it to help us. We have to do beta first. Okay, we have to. So we're going to forget about C and gamma for now. We're going to find beta. So let's set it up. So we're using row A and row B. For row A, we're going to set it up as sine of 40 over 3. And for row B, sine of beta over 2. Now, I want you to look at that proportion we just set up. There's something really different about that than the last two problems. What's different?
There's two numbers in the denominators.
Okay, so there's two numbers in the denominator, so where is the variable? It's inside the sine function. That never happened. The variable was always the letter in the bottom. Now it's not. So in the very end, we're going to have to get rid of the sine function somehow. And we talked about that a lot. So let's just solve it and see what happens. So we've got 2 sine 40 equals 3 sine beta. The goal is to get this by itself. So what would I do on each side? Divide by 3. So 2 sine 40 over 3 equals sine of beta. Now I have to get rid of sine. So how would I do that? Take the inverse. Now, before I even type that in, this said 2 sine 40 divided by 3 equals sine beta. If I just go back, I'm going to write that down again, but just look at that step right there. What kind of number would that be? If you type this all in, 2 sine 40 divided by 3, it would be a decimal, but what other kind of number would it be? Brandon kind of brought this up earlier with a number he got.
Negative.
He said he got a negative. Positive 2 times positive sine 40 divided by positive 3. What kind of number would that be?
Imaginary.
No, it's a positive times a positive divided by a positive. Positive. In what two quadrants is sine positive? 1 and 2. This is why there could be a second answer. Because sine equals a positive number in 2 different quadrants. How do you get the answer in quadrant 2? What is it? What's the formula again?
180
It's 180 minus what you got. So the first thing we have to do is just see, what do we get? Let's find the answer in quadrant 1. So second, inverse sine. Type that all in one step. 2 sine 40 over 3. Just like that. So this is not a no solution problem. If it was no solution, I would have just gotten an error, and the calculator would have said something different. 25.374 is a solution. So what I do is I write it up higher in the box in case there's a second answer. Okay. Now, to get the second answer, what did we say we do with that? I got 25.374. How would you get the second answer?
180 minus that answer.
180 minus that answer. So if there's a second answer to the problem,
That's so weird that there can be 2 answers to this problem. Like,
I'll draw it out sometime. Not today, but well, yeah, probably not today.
it's not there on the test, is it?
This problem, this kind of problem, yeah. Exactly what we're doing right here is going to be on the test. I'm not teaching anything that's not on the test. So if there's a second answer, it's 154.626.
That can't be
That can't be
an answer.
an answer to this problem. Why?
Because then you wouldn't have anything for, I forget what it's called, the last
Gamma?
one, and it would already be too big.
Right. In this problem, That's the second answer if it works, and algebraically it works. But practically in the triangle, it doesn't fit with a 40. It's too big.
Will that happen every time?
Sometimes the answer is, sometimes it works, sometimes it doesn't. The one on the test is going to be very similar to what I'm showing you right now.
Are we gonna know it's two answers, or like, are you gonna put down this is two answers, but he's not gonna do that? It's right there. On the test anyway.
You have to know if you're solving a side-side angle problem. That's where you check for the second answer. Okay?
Why would he tell us how many answers there
Yeah, I'm not going to tell you how many. But I'll say there's either 0, no solution, 1 solution, which is what this one is, or 2 solutions. I'll ask you that. The problem on the test is very similar to the one we're doing right now. Okay? So this 154.626, this second answer, you can ignore it. It's too big. We don't need it. Let's say the angle they gave you was 10, and somehow you got 154 for the second one. Then it would have worked, because 10 and 154 doesn't add up to more than 180. So to check if there's a second answer, you basically do exactly what I've been showing you. Would be in quadrant 2, so you subtract your answer from 180. Okay, I know I didn't find gamma yet. Gamma is super easy now that I have alpha and beta. I'll do gamma in a second. But before I do that, that's how you check for the second answer. Take what you got, subtract it from 180, and see if it's possible to fit that answer and the one you were given in the same triangle. And when I say see if it's possible to fit, what does it have to be under? It has to be under 180. If it adds up to more than 180, the second answer does not work. Okay, so then for our problem, I just went through and explained. I took 180, I subtracted the answer we got. We got 154.626. I already wrote that down in red up above. Right there, I put an X through it. And I put an X through it because if you add it up, it's greater than 180. That's no good. So this part I write out more for students that are taking trig, not pre-cal, because you guys should already know this. 180 minus the answer from the ASTC chart. But if you don't remember it, that's the explanation for how to find it. Okay, so the nice thing now is once you know you have one answer, you can forget the second answer for everything. This is going to be a normal problem from here. Nothing different. Okay. Now that I have alpha and beta, how would I get gamma?
You just
Yeah, they add up to 65.374. Just subtract that from 180. And now you finally have a piece of information in the last row. Okay. Now that I know gamma, what else can I find?
C.
Now I can get C. I have two choices about what row to use. I definitely have to use row 3. But should I use row A or B?
A.
Let's use A. How would I set up the left-hand side if I'm using row A? Sine 40 over 3. And how would I set up the right-hand side if I'm using row C? Sine 114,626 over C. Cross multiply, and you will get 3 sine 114 over sine 40. And you need to type that in and just see what you get. All I can tell you is it's going to be bigger than 3, but it has to be less than 5. Because whenever you add two sides up in a triangle, they have to add up to more than the third side. So it can't be bigger than 5, but it's got to be the biggest. So it's bigger than 3. But to get the exact answer, you gotta type it. Okay, any questions on that? So on the test, you're gonna have one of each type. Okay? Alright, so homework tonight on 435, it's 5 through 8, 10, 16, and these two questions. This is a separate question, that's a separate question. Okay, so I'll put those in the video in case you forget to copy them, but you should copy those two down. I'll be after school for extra help. Okay, remember that our test is tomorrow, okay, not on Friday. So Friday the plan is I'll pass back the test, go over it, and we'll watch. We're going to do something online. We're going to watch something from the internet.